In 2023, IBM announced it was pausing hiring for approximately 7,800 roles that artificial intelligence could fill. The statement landed like a thunderclap across corporate America. Every business journal ran the headline. Every earnings call referenced the strategy. The logic appeared airtight. Eliminate the cost of human labor, replace it with a system that works 24 hours a day, never asks for a raise, and scales without friction. IBM's chief human resources officer said the automation would be complete within 5 years. The savings would be in the hundreds of millions. And then the numbers came in. Enterprise-wide AI initiatives at IBM generated a return on investment of 5.9% against a capital investment that exceeded 10%. The savings were real. They were simply smaller than the costs.
This is not an isolated case. It is a pattern. Klarna, the Swedish payments company, replaced approximately 700 customer service agents with an AI assistant built on OpenAI's technology. The chatbot handled 2/3 of all customer conversations in its first month. It was, by every metric the company measured, a success. The CEO called it proof that AI could already perform every job humans do. Then customer satisfaction collapsed. Complex issues went unresolved. The cost savings projected in the initial announcement did not fully materialize. And by early 2025, Klarna was quietly rehiring human staff, some of the same individuals it had let go, because the AI could not handle what the humans could. The CEO admitted they had, quote, focused too much on efficiency. That admission is more important than the original announcement. The pattern extends further. Air Canada's customer service chatbot fabricated a bereavement refund policy that did not exist, advising a customer he was entitled to a discounted fare. A tribunal ruled against the airline. It was liable for its AI's hallucination, forced to honor a policy its system had invented. The legal cost, the reputational damage, and the customer service failure together exceeded what a human agent would have cost by an order of magnitude. Goldman Sachs' head of global equity research published a report titled "Too Much Spend, Too Little Benefit," asking directly whether the $1 trillion committed to AI infrastructure would ever generate adequate returns. These are not the voices of AI skeptics on the margins. These are the institutions that built the infrastructure, and they are asking the question, what if the math does not work?
To understand why AI so frequently costs more than it saves, you have to understand what the AI industry pricing structure actually contains, and more importantly, what it does not. When a company evaluates an AI deployment, it typically starts with the tool cost. The subscription, the API call rate, the enterprise license. That number is what vendors quote. That number is what procurement teams evaluate. And that number is, in almost every meaningful sense, the least significant number in the actual cost equation. The true cost of deploying AI at an enterprise scale has 5 components that vendor pricing never captures. The first is infrastructure. Enterprise AI requires compute, either cloud infrastructure rented at significant ongoing cost or hardware purchased at significant upfront cost. Cloud AI infrastructure costs have grown 40% year over year as demand outpaces supply. The second is data preparation. Before any AI system can function reliably, the data it operates on must be cleaned, structured, labeled, and integrated. This process routinely costs more than the AI system itself. The third is integration. Connecting AI to existing enterprise systems, software stacks built over decades with legacy architecture and inconsistent data formats, is not a configuration task. It is an engineering project measured in months and millions.
The fourth cost component is maintenance. Unlike traditional software, which functions correctly until something breaks, AI models degrade silently. A model trained on 2023 data begins producing worse outputs as 2024 conditions diverge from what it learned. Customer behavior shifts, regulations change, competitors move. The model does not know. Retraining to correct this degradation adds 15 to 30% overhead to the original deployment cost, and it must be repeated indefinitely. The fifth component is the cost of failure. When a human makes an error, its scope is limited. When an AI system fails, it fails at scale,
producing incorrect or harmful outputs across thousands of interactions before the error is detected. Compliance fines under frameworks like the EU AI Act can reach 35 million euros per incident. The happy path cost that vendors quote assumes the AI works correctly. The real cost includes every time it does not.
When you add these 5 components together, the picture changes completely. A 2024 MIT study, funded by the MIT Watson AI Lab, examined the technical requirements for AI systems to match human performance across a range of real-world roles. The researchers did not find that AI was simply slower or less capable than humans. They found something more structurally significant. At current compute costs, automating the majority of AI-exposed tasks is not economically viable. When the full cost stack is applied, the infrastructure, the data preparation, the integration, the maintenance, and the failure costs, human workers remain cheaper in 77% of roles studied. AI automation only wins on cost in 23% of the evaluated positions.
Brian Catanzaro is the Vice President of Applied Deep Learning at Nvidia. Nvidia is the company that manufactures the graphics processing units that AI systems run on. If there is a company with structural incentive to believe that AI compute is economically superior to human labor, it is Nvidia. Catanzaro made a different argument. For my team, he told Axios, the cost of compute is far beyond the costs of the employees. The company building the chips that power the AI cost revolution is finding internally that the chips cost more than the people. This is not a philosophical position, it is a budget line. And it is one of the most consequential admissions in the economics of the AI transition. The MIT study and the Nvidia admission point to the same underlying structural reality. AI's cost advantage is not universal. It is task-specific, scale-specific, and infrastructure-dependent in ways that most deployment strategies do not account for. The companies that saved money on AI did not simply automate a workforce. They identified the precise, narrow categories of work where AI's cost structure beats a human's, and they deployed AI only there. The companies that lost money did the opposite. They started with the AI system and asked what it could do rather than starting with the cost problem and asking whether AI was the right solution.
Where, then, does the cost advantage actually exist? The MIT study's 23% figure is not random. It clusters around specific characteristics: high-volume, low-variance tasks, processing insurance claims that follow a predictable structure, categorizing support tickets into predefined buckets, extracting data fields from standardized documents, generate genuine AI cost advantage at scale. The key word is scale. A human agent handling 100 support tickets per day costs the same as a human agent handling 80. An AI system handling 10,000 tickets per day costs the same per ticket as one handling 100. The per unit cost of AI drops with volume in a way that human labor does not. The cost advantage of AI is a volume advantage. At low volume, it disappears entirely. Where does the cost disadvantage live? In complexity, judgment, and consequence. Klarna's AI chatbot failed not because it could not read customer messages. It failed because resolving a customer's billing dispute, navigating an emotionally escalated complaint, or applying policy exceptions across unusual circumstances requires the kind of contextual judgment that current AI systems cannot reliably replicate. When those interactions fail, the downstream costs, churn, legal exposure, reputation, exceed the labor costs the AI was supposed to eliminate. Air Canada did not lose a legal case because its chatbot was slow. It lost because its chatbot invented a policy. The cost of that failure was not the chatbot's operational expense. It was the cost of having an AI system that customers trusted and that could not be trusted.
IBM Institute for Business Value Data captures this precisely. Enterprise-wide AI initiatives achieved an average return on investment of 5.9% against a 10% capital commitment. But the distribution inside that average is not uniform. Back-office automation, processing invoices, verifying documents, running standard data workflows, generated strong ROI. Customer-facing AI, the chatbots, the automated response systems, the AI that replaces human judgment in real-time interactions, generated most of the failure cases. The same technology produced opposite outcomes depending solely on where it was placed. The tool was not the problem, the placement was. And most companies, driven by what IBM's own CEO survey found, 64% of executives investing in AI before understanding its value because of fear of falling behind, made the placement decision first and the economic analysis never.
This is the AI illusion at its structural core. The illusion is not that AI is ineffective. In the right deployment, at the right scale, for the right category of task, AI generates cost advantages that are real and compounding. The illusion is that cost advantage is general, that it applies across the workforce the way executives announced it would, that replacing human judgment with a system trained on historical data is equivalent to replacing a repetitive data processing task with a faster data processing tool. It is not. The economic architecture of human labor and AI compute are different in ways that matter differently depending on what the work requires. Mistaking one for the other is the source of every failure case this video has examined. The question that matters now is not whether AI is expensive today. It is whether it will get cheaper and fast enough to change the math before the companies that bet on it run out of runway. Goldman Sachs' Jim Covello put the challenge precisely. Replacing low-wage jobs with tremendously costly technology is basically the polar opposite of the prior technology transitions I've witnessed in my 30 years of following the tech industry. The transitions that worked, the internet, cloud computing, the smartphone, made expensive things cheap. They brought capability previously only available to large organizations down to the individual level. The current AI transition is doing the opposite. It is making formerly affordable human capability more expensive to replicate than it was before. But the trajectory of compute cost is real, and it matters. GPU prices have fallen. API costs for frontier models have declined significantly year over year. The compute required to run an AI system capable of performing a given task in 2023 costs less in 2024. And less again in 2025. If this trajectory continues, and the consensus view among infrastructure analysts is that it will, the 23% of roles where AI is currently cost competitive will expand. The MIT study's own authors noted that a rapid decline in compute costs or wider deployment via AI as a service platforms could meaningfully accelerate the economic viability threshold. The cost problem is not permanent, but it is also not dissolving at the rate that corporate announcements implied it already had. There is a second factor that changes the future cost picture: specificity. The AI deployments that have generated reliable cost advantages are not general systems applied broadly. They are narrow systems trained on domain-specific data for precisely defined tasks. A general language model deployed as a customer service agent is expensive and error-prone. A fine-tuned model, trained specifically on a company's product documentation and support history, handling only the ticket categories it has been validated on, produces dramatically different economics. The companies that will win the cost equation are not the ones that deployed AI fastest. They are the ones that deployed it most precisely. The ones that treated each task as an independent cost-benefit decision rather than a single organizational mandate. What does this mean for the businesses that have already committed? The ones that made the Klarna bet, that replaced human workers wholesale based on a cost model that didn't hold? The short answer is that most of them already know. The IBM survey of 2,000 CEOs found that only 1 in 4 AI projects delivered the return it promised. The NTT data analysis found that between 70 and 85% of generative AI deployment efforts failed to meet their target ROI. These numbers are not projections. They are audit results on decisions already made. The correction is already underway. The companies doing it well are the ones that stopped defending the original announcement and started asking the question the announcement should have opened with. Exactly which task, at exactly what volume, at exactly what error tolerance, does our AI deployment beat a human on cost?
The answer to that question is always smaller than it first appears. And that is the insight that changes how you read every future AI announcement. When a company says AI is replacing its workforce, the relevant question is not, can AI do those jobs? Most AI systems can approximate most jobs under ideal conditions. The relevant question is, what does the full cost stack look like over 3 years, including infrastructure, maintenance, error, and integration? That is the question that the Klarna rollout didn't answer. That is the question the IBM forecast didn't answer. That is the question Goldman Sachs' Jim Cavello finally forced into the open when he published a report asking it directly from the inside of one of the most powerful financial institutions on Earth.
The operators who understand this are not abandoning AI. They are deploying it surgically. They are identifying the narrow task categories where the volume is high, the variance is low, the error tolerance is forgiving, and the AI cost structure wins definitively. They are leaving the complex, high-judgment, high-consequence interactions with humans not because they're sentimental about labor, but because the cost analysis says to. They are watching the compute cost trajectory, and they are preparing their organizations to expand AI's footprint as the economics improve, rather than having already made irreversible workforce decisions based on where the economics are going. The difference between these operators and the ones running the corrections is not intelligence or resources. It is one decision made earlier. Run the full cost analysis before the announcement.
The AI illusion is not that artificial intelligence is incapable. It is that capability and cost-effectiveness are the same thing. They are not. A system can perform a task and still cost more than the human it replaced. It can handle the volume and still fail on the edge cases that generate the litigation. It can show productivity gains in the first 6 months and produce negative ROI over 3 years once the maintenance and retraining costs arrive. The $1 trillion committed to AI infrastructure is not wasted, but it is being spent by organizations that have not asked the right question. The right question is not what can AI do? The right question is what does it cost to make AI do it reliably, at scale, over time? That question has an answer. Most companies have not wanted to hear it, but the ones that run it first and build their automation strategy around its honest output are the ones that will actually save what the announcements promised.
And as always, the world keeps changing. Change itself is like a cloak sewn to the back of our existence. Subscribe so you always know what's changing and, more importantly, what to do about it. Take care, and I'll see you next week.